Next our topic is electric field. Electric field means the region in which charge exert a force. So next we have to study intensity of electric field. Intensity of electric field, which is defined as the force experienced per unit positive charge. So E is equal to F by Q. And this electric field, which is a vector quantity. So we have to represent the electric field in vector form as vector E, which is equal to vector F by Q. And the unit of electric field is, the unit of force is Newton and the unit of charge is Coulomb. So the unit of electric field is Newton per Coulomb. And next we have to calculate the dimensional formula of electric field. So here the dimensional formula force is M L T raised to minus 2. And the dimensional formula of charge is A into T. So that here you just consider the dimensional formula of charge is at A T. So when we simplify this equation, we get M L T raised to minus 3 ampere raised to minus 1. So this is the dimensional formula of electric field. And next we have to write the equation of electric field intensity at a point, electric field intensity at a point due to a charge. Here the equation used to calculate electric field intensity is E is equal to Q by 4 pi epsilon 0 into R square. So here also the electric field intensity is a vector quantity, but here charge is a scalar quantity and distance is also a scalar quantity. But electric field intensity, which is a vector quantity, so to represent electric field as vector, we have to use a unit vector here. So that vector E is equal to Q by 4 pi epsilon 0 R square into R cap. R cap represent unit vector. Unit vector means it has unit magnitude, but it is used to represent the direction. Therefore, electric field intensity is a vector quantity and the direction of electric field is same as the direction of force. So next we have to study what is meant by electric dipole. Electric dipole electric dipole means two equal and opposite charges separated by a small vector distance is only said to be an electric dipole. So here one is positive charge plus Q and another one you can take minus Q. The two charges are same in magnitude, but they are separated by a small vector distance. This is only said to be an electric dipole. And next we have to study electric dipole moment. Electric dipole moment, which is represented by the letter P, which is equal to the product of either of the charge and the length of the dipole. Here the distance between a positive charge and a negative charge, which is taken as 2a. This 2a is only representing the length of dipole. Okay, therefore dipole moment which is equal to the product of either of the charge and the length of dipole. P is equal to Q into 2a. And the unit of this dipole moment which is coulomb into meter. The unit of charge is coulomb and the length of the dipole it is meter. So coulomb meter is the unit of dipole moment. And here this dipole moment is also a vector quantity. It is a vector quantity. Here we can represent vector P which is equal to Q into 2a into P cap. Here also the charge is a scalar quantity, length of dipole is a scalar quantity. So to represent dipole moment as vector quantity, here we are using a unit vector. So dipole moment is a vector quantity. So vector P is equal to Q into 2a into P cap. And the direction of dipole moment is just opposite to the direction of electric field. Electric field, the direction which is always moves from positive charge to negative charge. The direction of dipole moment which is negative to positive.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.